So I will share my screen. So today we have another interesting topic, which is data analysis and reporting. And what we will do today is that we will try to get some data from the simulator. We can use the sensor data. And after that, we will use this data to analyze it and find some patterns in it, or create some graphs. Do you have any experience with statistics? Have you learned it in university? Okay, and stuff like standard deviation and mean, are these familiar to you? Like, maybe you also know that.
No, I don't remember. Maybe I will.
Okay. Okay, so if you're following with me here, you can open Visual Studio Code as usual, and I will also open the simulator. And you probably cannot launch the simulator, right? Because you're on Mac.
Yes.
Okay, that's unfortunate, but you can follow data.
Yes, I will.
Great. Okay, let's open this. Here is our simulator, and I'll just quickly run it in API only mode so that it is ready. Yeah. Let's also create a new folder for this project. Let's call it data analysis. Okay. Actually, we don't need Visual Studio Code for that. I'll just open terminal. Today we will be writing Python in a bit different way. There is this really nice tool called Jupyter Lab, and it allows you to write Python code in a kind of a notebook environment. I think it will be easier to see it in practice. So it should come with your Anaconda installation. If it doesn't, you can install it with PIP. So that's you open it using this command, Jupyter Lab, and it will open in the browser, and you'll get an interface like this. And this Jupyter Lab, it is often used in data analysis tasks and stuff like machine learning, where you have some graphics and some visual stuff. Because if you're running the Python in console, it is like hard to get this kind of visual information. So you can create a new notebook. Let's call it sensor analysis. And this works just like the Python console. So you can enter Python commands here. For example, let's do a hello world. And then you hit play here, or you can click Shift plus Enter, and it executes it. And like really nice thing about this that you can, for example, execute it again. So you do not need to write your whole program in advance. How to open that lab? You open it from terminal. Okay, let's do it again. I'll save this one. let's close it. You just enter Jupyter Lab. It should be installed for you already. If not, just write it and yeah, as I remember, you already had the Anaconda, so it should be working for you. Yeah, right if you manage. It says access denied. Access denied. Try to open it in a different folder, like for example on desktop. You can open terminal on desktop. Access denied. Oh, also on Windows, you can also open this Anaconda browser, which I do not have here because I'm on Linux. And you can also open it from Anaconda Navigator. Try to do that, and I'll wait for you. So, did you open it? Really nice. Yes, so where was I? Yeah, so nice thing about this is that you do not need to write your whole code in advance and then execute it and hope that it will all work. With this approach, you can just write short snippets and like write it step by step, and also you're able to execute it step by step. And you can also include some comments here. So, for example, you can create some sections, like section 1. And hello world. So it like works as a notebook. So you can also add some comments to it. You can even add some images, and we can basically do everything with this. And we will, could you please zoom in a little? Let me try. Yeah, like that. And I will try to run our LGSL API from here. Let's start with the import command. I will also open this seminar on the side so I can see. Yeah, so as before, we import LGSVL and then connect to the simulator. LGSVL simulator. This is all what we did previously. Address equals localhost. Port equals 8181. Let's run it. So API ready. Now let's load some scene. For example, we can create San Francisco. Like this. Let's wait, and we have San Francisco here. And let's also spawn our vehicle. So let's also create the state. LGSVL agent state. State. Let's move it a bit vertically because it usually spawns it beneath the ground. So if you remember, it is y-axis, which is vertical position. And let's create our ego. Okay, let's see which kind of vehicles we have. So let's use something that has sensors, many sensors on it. Okay, for example, let's do this link home. It has canvas, odometry. It will be nice to use if we can extract GPS data from it. Let's search for GPS. Yes, it has GPS. Okay, we can just use this one. And of course, write in the chat if you're not able to follow if I'm doing it fast. So like that. Agent type is ego, of course. And state equals state. Let's see. Yeah, so it is spawned. The nice thing is that like you can really quickly reset it. For example, if you want to move it a bit lower, you'll just click reset here, and yeah, it is reset. Okay, this is too low. Let's try 12. It's okay, I guess. So now let's try to get some information from the sensors. So now it is like simulation is not running, so we will only be able to get like current snapshot. For example, we can get current position from the GPS, or we can get actually let's get a picture. Let's try to get a picture from the main camera. So the way we access the sensors is using ego get sensors. Yeah, so it returns some sensors, and we can loop over these sensors, and when we get the camera sensor, we can get a picture from it. So let's see how we can do loops in Python, because as I remember, it wasn't. We hadn't done it in any of the seminars. So looping is when you want to do something on multiple elements. For example, if you have some list which contains some numbers, and for example, you want to print all of it one by one. So you start with 4. So the statement here is like for each element in the list, we want to do some stuff. So for element in list, and this element, it's just the name of the variable. We are creating a new variable. You can call it anything you want. Then we do a semicolon and print element. So this will happen for 1, then for 4, then for 7, then for another 4. So let's run. So we get correct. Let's also try some math. Yeah, same thing. So these sensors, as you can see, it is also a list. So we can also loop over this list. So, for example, for sensor in ego.getSensors, semicolon, and let's, for example, print the sensor. Yeah, so we got the same result as here, but like we don't have this list characters here. Okay, let's delete this one. And actually, sensor also has a name, so we can also print their names. Okay, so as you can see, we have GPS sensor, CAN bus, some LiDAR, radar, and we also have 2 cameras. So now what I want to do is to get a picture from this camera. So we can add an if statement here. So if the name of the sensor is main camera, then for this camera we have this method save, sensor.save, and of course you can also check these comments in LGSVL API documentation. Let's see, API guide and sensors, camera sensor. And so we have almost the same example here, and we can do sensor save, name of the file, and we can also specify some compression. So let's save it. Camera photo. Let's just call it photo.png, and I think it will have the default compression as well. Okay, let's see if it created any files. I'll just open this folder. I cannot really see the photo here. Maybe it's saved in home folder. Yeah, it's a bit weird. It didn't save the photo for us.
Maybe it needs to run the simulation first. I don't know.
Save method accepts the. Oh, okay. It's relative to the simulator, so it probably saved it in the simulator folder. Yep, here it is. So this is what our car sees. Yeah, so it saves it in the simulator folder, not in the API folder. Okay, we can now also get an information from GPS sensor. Let's see. So actually here, yeah, they have it incorrectly. So it shouldn't have this braces here. It is a property, it's not a method, so you don't need braces there. They have wrong documentation there. So let's. So now instead of main camera, I'll get GPS. Let's print the names because I don't remember. So it's just GPS. So again, if sensor name equals GPS, then we want to get GPS data, and let's print it. Yes. So this GPS data, it includes latitude, longitude, northing, easting, altitude, orientation. So this latitude and longitude, these are the specified coordinates around the Earth. This is also similar, but latitude and longitude, they specify coordinates on the sphere, and this northing and easting are different kind of coordinates where they specify it on a flat map. So this is the difference between them. And in case of latitude and longitude, these are values from 0 to 360. So 360. So for example, if you start on the top, then 180 will be on the bottom of the Earth, and 90 degrees will be on around equator. This for latitude, which is like vertical. And northing and easting, northing is like vertical, easting is horizontal. And altitude is how high you are from, probably from sea level. So in our case, it will be, so in our case, it is just y coordinate. And we also have orientation, so where our car is looking. In this case, it's looking forward, so it is 0. Now, this sensor data has a special data type, GPS data. We can convert it to a dictionary, which is Python built-in type, so it will be easier for us to work with that. And for that, it has this method as dict. So meaning as a dictionary. And so it is converted to this dictionary. Now, dictionaries are similar to the list, but where in the list you can access the elements by their indices. So for example, we want the first element. Now, in case of dictionary, you can call each element some arbitrary name. So for example, I want the name to be Levan, for example. And my profession, the developer. And then I can access its elements by their names. So instead of indices, so I get level. So it is like a dictionary for example, converted from one language to another. So you find some word by name, and you find its translation or its explanation. Okay, so in our case, we have this coordinates in a dictionary. So let's save it. For example, let's call it GPS data. Don't like this anymore. And we can access it in a similar way. So for example, latitude. We can get it. So now this information, we cannot really analyze this information because we just have the coordinates for just like single time frame. What would be more interesting is to run the simulation and get these coordinates, for example, in like short periods of times, and in the end we will have like lots of coordinates, and it will contain the information of how our car changed its position over time, and then it would be like more interesting data to analyze and to report. So for that, what we can do is run the simulation in with some short time frames, and we can drive this car ourselves. And after the end of the time frame, we will just save this snapshot in the list, and on each end of this run, we will just save this GPS positions, and in the end we will have a list with lots of positions, and we can then proceed with analyzing it. So one problem that we may have here is that when it will finish running, it will have a little delay in which it will save this data from GPS, and after that it will immediately continue. But we may get some lags because of that. So we can see how it goes. So what we can do is, if you remember the command for running, it's running, run, simulation run, and we specified some time limit. Let's do some short time limit, like 0.5 seconds, so 500 milliseconds. Let's try to run it. Yeah, so it's it already finished because it's so short. So now what we want, we can again use the loops to run it several times. And for this, we will use this range function. What the range function does is that it returns some numbers in a range. So for example, for each number in a range from 0 to 10, let's print that number. I forgot in there. Yeah, so like that. If you're starting from 0, you can also omit it, and so it will give you the same results. You can also do from 5 to 10, for example. And we can use it to run our simulation. Let's try 100 times because we have a short time span. So in this case, we will get 0.5 times 100. We'll have 50 seconds, so almost a minute for it. Okay, so we can put this in here. So we run it for half a second, 100 times. And now after each run, we want to get the sensor data. For sensor in Eagle, get sensors. Let's just copy it. Yes, so like that. So now with this approach, it will just override this GPS data. So in the end, we will just get the last GPS information. Instead, what we want is to create a list and store each of those GPS positions in this list. So we can create GPS data as a list. We create list with square braces. Oh, it's just an empty list. It doesn't contain anything. And if you remember the command for adding elements to the list, it is list.append. So append means add additional element to the end of the list. And we will append this one. Okay, so let's check that everything is correct, and then we can run the simulation, have some driving, and then see what kind of data we get. So we create the list, empty list, then for 100 times. So here we don't really use the I here. We just use it for doing the same thing 100 times. In such cases where you do not use a variable, there is this convention to use underscore. So it is just a name for this variable, but we like explicitly show to others that we are not using it. So for 100 times, we run the simulation for half seconds. Then after each run, we get our sensors. We find the GPS sensor, and we append this data from the sensor to GPS data. Okay, let's run it. And we can drive our car. Yeah, so as you can see, it lags sometimes. This is actually not because Python takes that much time to get this data from sensor. This lag is because of this delay in the connection, because this API connects via network, so it has some delay in the connection. But it is still drivable. Okay, so we have 50 seconds to drive the car. Okay, that's all. Okay, let's see if we have any data. GPS data. Yay, we have the data. So as you can see, we have these coordinates, and there should be 100 of them here. And it is a bit hard to work with this kind of data where we have this list, and in the list we have some dictionaries. So we will use a really nice Python library, which is often used with data analysis, and it is called pandas. So let's clear this one. Here, output. Okay, let's look at pandas. Python data analysis library. And so if you're new to it, you can read a user guide for it. It is pretty easy to use, very straightforward and like beginner friendly. And the main thing in this pandas library is this pandas data frame. And you can think of data frame as like a spreadsheet, so like Excel. So you have a kind of table where you can put some data or where you can read the data. So if we again look at our GPS data, we can think of this data as a spreadsheet where we have some columns, latitude, longitude, and we have several rows of it. So for each time frame. So this would be like a good kind of data to put in a spreadsheet, like Excel. Let's import pandas. And when importing pandas, we often name it as PD, just to have a short name. I don't know how it started, but like this is a common trend to like import pandas as PD, and after that it's a PD. Probably pandas was like too long, and we want to create this pandas data frame, which is this spreadsheet. And as I said, it is really easy to use. So it will automatically like read from this kind of dictionary in a list structure, and it can automatically convert it to the spreadsheet format. So you can just put data here. And yeah, like the cool thing about this whole Jupyter is that you can have this kind of visualizations like tables. And let's save the spreadsheet in a variable. Let's call it GPS table, for example. And we also have this method, GPS table.head, which shows you some like first 10 or something like that. Okay, first 5 rows of it. So this is just to get some idea about the data without printing this whole table. Okay, so it looks really great. Now we can analyze it. And again, we will use some pandas functionality here. So pandas has lots of analysis functions built in. For example, one of them is describe. And what this method does is that it gives you some statistical information about this data that you have. So for example, we have count, which is number of rows that you have. Yeah, this one, it's just in scientific notation, but it is also 100. So we have some 100 rows as expected because we ran it for 100 times. We also have mean. Mean is the average value. If you sum all the values and you divide it by number of values, you get the mean, so the average value. We also have other statistical properties, like this is standard deviation. So if you do not remember it from statistics, standard deviation describes how much the values deviate from the mean value. So for example, if you have a data where most of the values are very close to the mean value, then you would have really low standard deviation. On the other hand, if you have a lot of spread between the values, so for example, your mean is 37, but you have values which are like 100 or 1000, and there are lots of this kind of values, then you have big standard deviation. So in our case, we have a really low standard deviation for the latitude because we're running it for a short time and like we haven't moved that much in this environment. We can also see the mean and max values. So they are like really close because like you need to understand that these are relative to the whole Earth, and like relative to the whole Earth, we moved like, by really small amounts. And you also have interquartile ranges. I will not go through them in depth, but they show in what kind of percentages this different values are put in this data. And we get this information for all all of our columns. Let's also look at orientation. Yeah, so it looks like we were moving in an, let's see how we started. So we started at 0, and then we had the maximum rotation at the beginning, and then we probably started moving on the left. So we almost did a full circle, so almost 360, but not quite. Okay, now let's try to build some graphs. Again, pandas contains ability to plot some graphs from your data. Pandas plot. So pandas data frame plot. And we can see what kind of plots we can do. So plots are just some kind of graphs which visualize your data. So it is like a good way to see your whole data in a snapshot, because like you cannot go through this 100 rows and analyze all of them manually. You want to have some global picture on your data. So we can, for example, use the line plot, which is the most basic plots. And it works on like one column. So you can see how that column changed over time. So latitude plot, just plot. I think that should work. Yeah, we have a graph. I think it will be more interesting to see the altitude. Yeah, it's so interesting. Yeah, I think we here it probably means that we went on the sideways. So it's a sideways is a little bit up. So we have this bump here, and then we moved again on the road, and later we also moved on a bump a bit. In this case, we started the simulation before as well. If we started the simulation here, it would first fall from the air because it started higher, but we haven't recorded that. In that case, we would have a little bump here as well, probably higher than this one. Okay, and we can of course do it for other variables as well. Let's see, orientation, for example. Yeah, so it is from 0 to 360, and we can see like how we rotate it over time. Okay, now another interesting plot would be the scatter plot. Scatter plot can show you the relationship between some two variables. So, for example, it will be interesting to see a relationship between latitude and longitude, or northing and easting. So, with this plot, we should be able to get a kind of representation of how we moved in the environment. So, in this case, we remove this one because we want to do it for several attributes here. And so if you look at the API, the way you create a scatter plot is like that. Table plot scatter, and then you have name of the column which you want to use as x-axis, so which is this one, and the one that you want for y-axis, which is this one. So what it will do is that, for example, if we use northing and easting, it will plot the x values right here, plot the y values, so easting will be here, and then on their intersections, it will put some dots there. So our x, let's use northing and easting. Then easting. Nothing. It's not nothing. Yeah, cool. So we thought it looks like we moved like that. So we probably, yeah, as I remember, that was how I moved. I went on this bump here on the sideways, and then I returned back. Yes, so I guess that is all with today's seminar. I will put the links about, for example, this pandas data frame documentation. It is like really flexible for data analysis. You can do lots of statistics, and you can create this kind of really nice tables and graphs. So if you have any questions, of course, you can write it in the chat.
Hi, Levan. Is it just to see different, this whole thing? Is just to see different stuff like position of the vehicle and in this kind of way? Or how would you use this, what we just learned?
Yes, in this case, I guess this example, it was like not really realistic, like how you would analyze it. You could actually use this information to, for example, check in which places your car was to like kind of get the coverage, for example, from the test cases of what kind of places you covered in this test case. So that would be one example.
Okay. Will we have homework on this case, on this subject?
Actually, I haven't. I don't have an idea for homework yet.
No.
Maybe later. But
No.
I think just doing the same thing at home and getting some data, it will be enough.
Okay.
And you could, for example, send this notebook, and it will contain all of this data.
One more thing. How were you quickly deleting stuff with the scissors, or you were?
Yes, I think I was deleting with scissors.
Okay. Thank you.
Okay, I guess if you don't have any questions, we can finish. Akaki, maybe you have any questions? Were you able to follow? Okay, no answers from Akaki. Yeah, you can of course write questions in the Telegram as well. Okay, that's it. Goodbye. Thank you for listening, and see you on the next workshop. Bye.